Vertical upward motion, problem number 15. A ball is thrown upward at 24 meters per second from the edge of a cliff and 7 seconds later lands at the base of the cliff. How high was the cliff? So let's start by sketching here. I'm going to sketch in this side this time, a cliff. So this is my cliff. And this ball is going to be thrown upward. Gonna go all the way up. And then it's coming all the way down, passing through the base of the cliff. And not the base of the cliff, but the edge of the cliff, and land on by the base of the cliff. So that's what's going on with this problem. So what we're gonna do here, we need to identify what is happening. So this ball is being thrown with a velocity of 24 meters per second. As it's going up, the velocity right here, final velocity here is 0. And it's going to take a time up to go all the way where the velocity is going to be 0 and then change the direction. So when the ball is passing by the edge of the cliff again, where it actually starts, and this velocity here, will be exactly the same value. So by symmetry. And it's going to take time down from where the ball stops up to the edge of the top of this cliff. And then it's gonna fall, and it's gonna take a time t that we don't know, that is going to land on the ground, on the base of the cliff. Now the other thing is saying here is the time the ball is staying in the air, the entire trajectory is 7 seconds. So which means the time in the air is 7 seconds. So the time in the air is is equal to the time that the ball is going up plus the time that is coming down up to here plus the time from the top of the cliff to the ground. Okay, so to solve this problem, to find the height of this cliff, which we are gonna call D, we need to find T. Because if you look, we have here three separate motion. We have going up from where it was thrown up to where it stopped in the air. We have coming down up to where change the direction to the reference where it was thrown. And the third one is from here to the base of the cliff. So we have 3 separate motion that we need to combine together to find the height of the cliff. So to do that, we are going to step by step find different things. Number 1, what do we need to know to find this distance, the height of this cliff? So if you build your table, which is VI, VF, DAT, if you build this table, so in this section, let's call here like this green section right here. So let's call this a green section, green section. So in this green section, our VI is 24. Our VF, we don't know, is the velocity that hit the ground. The distance, that's what we are looking for. The acceleration is acceleration of gravity, 9.80 meters per second squared positive. And we don't have this time. Okay, so we'll need to know this time in order to use these equations and find the height of the cliff. So for the height of the cliff, we can use this equation here, but we don't have VF, or we can find T and use this equation here. There you go. So we need to find T. To find T, we need to find time up. When we find time up is equal time down, and we can find T and solve for the problem. To find time up, so let me cut in section here. So find time up. So to find time up, we need to build our equation, our table, based on what is happening when it's going up. VI, VF, DAT. So our VI is 24 meters per second. Our VF going up is 0. Right here is 0. We don't know nothing about the distance, how high it went. The acceleration is negative because it's decelerating. And we need to find this time up. So now we're going to look at our equations, and probably our best option will be equation 1. So this here is VF is equal VI plus AT. VF is 0, VI is 24, minus 9.8 T up. So doing moving things around, we have this, we have done this before. Now we are going to divide by 9.8. So our T up is 24 divided by 9.8, which is 2.45, let's say. 45. So 45 seconds. So now our time, we are going back to this equation here. Time in the air is equal time up, which is 2.45. Time down is also 2.45. Time down is up to here. And plus T, that's why we need to look while we are searching. So the time in the air, the total time in the air is 7, and this 2.45 times 2 will give us 4.9 plus T. So our T here is 7 minus, will be 2.1 seconds. So this information needs to be moved to this right here. So these need to come to this section. So now that we have all this, we need again to find which equation we can apply to find the height of this cliff. So we are looking for, and we discussed this before, so we probably are gonna use this one, the second equation. So D is equal VIT plus half AT squared. So D is VI is 24. The time is 2.1 plus half times 9.8, and 2.1 is square. I just did the substitution. Now we are going to solve. I just type this on the calculator. 24 times 2.1 plus this is 4.9, 9.8 divided by 2 times 2.1 square is 72 meters. So the height of this cliff is 72 meters. And that is our final answer. It's just like a multi-step type of problem, and there is a lots of you need to have a knowledge about all these type of motions and what that means, being the time in the air, and apply the correct equation and done.